Hello everyone, this is Oshani from Cheenta.com. So today we will be discussing a problem from American Math Competition. We discussed this in the number theory module of the American Math Competition review course at Cheenta. If you want to know more about our programs for Mathematical Olympiads, check the link in the description. We have many exciting programs. In fact, we recently launched the AP Statistics programs, which also comes with a research add-on. It's very exciting. I have also put the link of that in the description. If you want, you can also join our statistics programs. Now, let's come back to this one. We will learn two concepts using this single problem. The first one is a very useful factorization problem. Though you do not need this factorization for this particular problem, we will nevertheless use this pretext. We use this opportunity to look into this factorization. And the second thing is modular arithmetic. It's another interesting part of number theory. Again, we do not need modular arithmetic for this, but we will use it to solve this problem. All right. So let's get started. What this problem says is that if you have this expression 3 to the power 0, 3 to the power 1 up to 3 to the power 2009. You add them all up and you divide it by 8. You add 3 to the power 0, 3 to the power 1 up to 3 to the power 2009 and you divide it by 8. What is the remainder? That's the question. So we will see how we can do this. If you are new to this channel, welcome. We discuss everything related to mathematical sciences here. Math Olympiad, Physics Olympiad, Informatics Olympiad, ISI-CMI Entrances and research projects for school students and college students. So if you want to know more about that, check the link in the description. We are very passionate about mathematical sciences. I'm sure you'll find something that you will like. So let's do this. The first thing is about the factorization. Factorization. As I told you, you don't really need it to do this problem. But you know how I do it. I start with a problem and try to trace back to concepts. That way it is more fun. So what is this factorization? Is this that x minus 1. So it's a factorization of x to the power n minus 1. What it is? It is x minus 1 times x to the power n minus 1, x to the power n minus 2, up to x square plus x plus 1. This is the factorization. Now, one way to see why this factorization is true is that you can just multiply stuff out. You can multiply it with x, everything. If you multiply it with x, you could do that. So what you get is x to the power n, x to the power n minus 1 up to x cubed plus x squared plus x, right? And if you multiply it with negative 1, you will get negative x to the power n minus 1. So negative 1 into this, negative 1 into that, and so on up to negative x squared, negative x to negative 1. So if you add it up, everything will cancel off except the x to the power n and minus 1. So you get the left hand side. Okay? Alright. So this is a very useful factorization and you can readily use it in this particular expression to simplify it, to make it more compact. So one way to look at this is x to the power n minus 1 plus x to the power n minus 2 up to x to the power 0. That is, 1 is x to the power 0. This is x to the power n minus 1 divided by x minus 1. So in our case, we have 3 to the power 2009, 3 to the power 2008 up to 3 plus 3 to the power 1 to the power 0. So that would be 3 to the power 2010 minus 1 divided by 3 minus 1. which is 3 to the power 2010 minus 1 divided by 2. So you want to know what happens if you divide this by 8. What is the remainder when you divide this thing by 8? There are various ways of doing this, but you can start off from here as well. So one way, so here is one way. You recognize that if you divide 3 square by 8, that is 3 square is 9, so if you divide 3 square by 8, the remainder is 1. 3 square divided by 8, 9 divided by 8, remainder is 1. In the language of modular arithmetic, now if you don't know modular arithmetic, shall the link in the description. We have some tutorials on modular arithmetic. If you are attending the Math Olympiad program at Cheenta, you should also do a very extensive discussion on modular arithmetic. We are interested to understand it algebraically as well as geometrically. Both ways should be there. Okay, so 3 square is congruent to 1 mod 8. A brief sort of recap of it. We say that A is congruent to B mod M. A is congruent to B mod M. This means A minus B, the difference of A minus B is divisible by M. That's all it means. A to B, if you look at it on the number line, A and B, 2 points, the distance between them is divisible by M. That's when, if that happens, we say is A is congruent to B mod M. So 3 square is congruent to 1 mod M. We can raise both sides to the power 1005, and we immediately get 3 to the power 2010 is congruent to 1 mod 8. Wait, so how can we raise both sides to the power 2005? So this is not easy. This is a theorem, and you have to check. It's not immediate. You have to check something, that if A is congruent to B mod M, then you can raise both sides to the power something. So then A to the power K is congruent to B to the power K mod L. So one way to do this is that you check that M divides, that's the definition, right? M divides A to the power K minus B to the power K. And you can always factorize A to the power K minus B to the power K as A minus B times something. Since you already know that A minus B is divisible by M, therefore this thing will also be divisible by M. So you can raise both sides to the power K. That is possible. Alright, so we know that 3 to the power 10, 3 to the power 2010 minus 1 is congruent to 0 mod 8, which essentially means 3 to the power 10, 2010 minus 1 is divisible by 8. It's divisible by 8. Now there is something tricky going on here. You really don't want this. You want 3 to the power 2010 minus 1 divided by 2. You want to know what happens to this quantity when you divide it by 8. So whatever this quantity gives remainder as, let's say that's x. This is modulo 8. Whatever this quantity gives remainder as, you can check that 3 to the power 2010 minus 1 is equal to 2, is congruent to 2x mod 8. So whatever 2x is, so 2x is 0. We already know that this is 0 mod 8. So 2x is congruent to 0 mod 8. So what is the value of x? So x could be either 0, okay, if x is 0 then 2x is 0, or x is 4. If x is 4, 2x is 8, so x could be 4. In either of those two situations, we don't get a definite value of x, but we get a sort of a ballpark value of x, okay? So if x is congruent to 0 mod 8, that means that 3 to the power 2010 minus 1 divided by 2 is divisible by 8, right? If x is 0, that means this quantity minus 0 is divisible by 8, so this quantity is divisible by 8. Which means that 3 to the power 10, 2010 minus 1 is congruent to, is equal to, divided by 2, is equal to some 8 quotient, 8 times a quotient, or 3 to the power 2010 minus 1 is equal to 16 sometimes some quotient. So is this quantity divisible by 16? That's the question. Is it divisible by 16? So you can again check that whether it is divisible by 16 or not. For example, you could write 3 to the power 4 is congruent to 1 mod 81, 1 mod 16, sorry, because 3 to the power 4 is 81, and if you divide 81 by 16, the remainder is 1. Now, to go up to 2010, you can raise both sides to the power 502, let's say. Mod 16. So 3 to the power 2008. So 4 times 502 is 2008 is congruent to 1 mod 16. And you can multiply both sides to the power 3 square. So 3 to the power 2010 is congruent to 9 mod 16. So it's not 0 mod 16. So this is not true. This thing is not true. Okay, this is not true. It's not divisible by 16. 3 to the power 2010 minus 1 is not divisible by 16. It produces a remainder. If you just subtract 1, the remainder is 8. So it is not divisible by 16. So we know that this particular case is not possible. So x is 4. X must be 4. So the final answer is 4. Okay, so this is not the best way to do this. So another student, Siddharth, he pointed out another way of doing this, which is basically observing that if you take 3 to the power 0, 3 to the power 1, 3 square, up to 3 to the power 2009, that each of these produces remainders 1, 3, 1, 3 alternatively. If you divide by 8, 3 to the power 0 produces remainder 1, 3 to the power 1 produces remainder 3, 3 square produces remainder 1, 3 cubed, that is 27. If you divide that by 8, it produces remainder 3, and so on. So it becomes 1, 3, 1, 3, one after another. So you can simply do this. 3 to the power 0 is congruent to 1, 3 to the power 1 is congruent to 3, 3 square is congruent to 1, 3 to the power 4 is congruent to 3, and 3 cubed, sorry, and up to 3 to the power 2009 is congruent to 3. So you add them all up and you can do some modular arithmetic and find out the remainder. You have to actually show a couple of things, that 3 to the power 2k is always congruent to 1 mod 8, and 3 to the power 2k plus 1 is congruent to 3 mod 8. So this is very easy. You can probably show it in the comment section and tell me how it looks like. But once you show this, you are basically mathematically confirming this pattern 1 3 1 3 1 3 like this. Okay, so Of course, you observe a pattern, but it is another thing to prove it. So this is the proof. Can you show it in the comment section? So once you do it, you can just add it up, and then that sum will be something very small, and you can finally divide that with 8 to find the final remainder. So that is the easier and the right way to do this. But the only reason I did it like this, because I wanted to give you a tour of this factorization formula, which is very important, by the way. And I also wanted to give you a tour of how modular arithmetic actually works. Sometimes you have caseworks and you have to carefully go into it and understand what's going on. All right. So think about it. I hope you learned something. If you did, please consider subscribing. If you want to know more about our courses, check the link in the description, and I'll see you in the next video. Thank you. Goodbye.